download it from the source if you would like. After you have set your parameters to go and print, again, how hot are you printing, what material, how thick, big, tall, you will export that as a G-code file. I apologize, I do not remember what the G stands for. I'm going to guess off the top of my head as geometry, but I'm just going to assume, and you never should assume, but it is the geometrical format of which your machine needs to move to go and build the part. So each step by step, we can look after, I don't have one on today, but we can actually look after in a text document what G-code looks like. It's very human readable, which is really nice. That's your printing software. That's the file format that you need to print. It's not the STL file. People get that confused. G-code prints. STL is your model to be prepared for printing for your slicing software. Once you have that, again, tweak your printer, make sure you got your filament loaded, you're off to the races. These are, if you don't want to design any of your files, these are some great places, some locals as well, myself and others included. These are some really great sites to go and check out. I'll leave that up on screen really quickly. Thingiverse is obviously the top two are kind of the main ones. If you would like more Bitcoin specific or any product specific parts, CryptoCloaks has a great file factory. Guns.team if you're interested in other adjacent models. And we have just, I think I only got a few designs up on there. There's more designs on my GitHub, I know that. But there are hundreds of millions. I don't have actually on here, I should have added that. Printables. Print, ABLES.com. Printables.com is another great one. That's Prusa's site. But Thingiverse, Yegi, YGGI, you're going to find millions of designs for you to go and print, modify from there. So again, we're focusing mainly on Tinkercad today, but this is just a very, very light dip your toe in the CAD water, if you will. Computer-aided design. You kind of get the acronym. There's tons of different ones. You got Fusion 360, SolidWorks, I don't have listed up there, very popular. SolidWorks, Onshape is another web-based one. OpenSCAD for more programmers-based. You can actually go and write your own scripts and watch the model be built. It's pretty cool. We're going to focus on Tinkercad. Again, extremely basic, very simple, free to sign up. What you're actually doing here is you're just manipulating polygons, just obtuse triangles here. You're just at a kind of a nano level, you're just manipulating polygons to get your desired object. And again, what outputs that is your STL format. So go and look for files that say benchy.stl or benchy.obj. Those are files that are all readable. You can also, we made a few PlebLab signs as well, and I know some others did. There are some PlebLab signs that we created out of a 2D image. So you can take a two-dimensional image or a vector file and extrude that to make it a 3D object, and you can see some of those there. So if you are more familiar with laser cutting pictures and things like that, you can go and 3D print from a vector file. But we're going to focus on Tinkercad. It's tinkercad.com if you'd like to look at that. Follow along with me if you so choose. Again, it's free to sign up. You do not have to. This is just a quick demo, but we will go into that very quickly right now. So I've already logged in. I will just simply go and show a brand new design. So this is just your main dashboard. Again, it's very, people laugh when I kind of demo Tinkercad because it's really geared towards kids, but it does the job for very light work. If you're on the road or if you're doing something quick, you don't want to run a heavier CAD program. But you have different options. You can go and do circuit boards, so on and so forth, but obviously we'll focus on a 3D design today. So just kind of play around here and then I'll drag and drop something in and then we will actually slice that and print what we are going to be printing as we speak right now. So this is your work plane. Again, very, very simple in its GUI, very easy to understand. And you have these objects on the side and there's different variations. There's text, there's triangles, there's circles, squares, donuts, whatever else, many different things. There's creatures, so on and so forth. But the point here is you can go and build some very complicated things just by making some very simple adjustments in your work plane. Drag and drop a box, resize it, so on and so forth. So I don't want to get super crazy here, but let's just do something very simple. Let's just go and make a 20 millimeter cube. I'm sorry, we'll do a 50 millimeter cube. And we will put, I don't know if I got a Bitcoin logo ready. We'll just go and put a center in it. Maybe I got one saved. Got one saved here? I do not. We'll just go and put a hole in the center of it, just for an example. So you have solid objects. When you click on an object here, I did not make that 50. There we go. Okay. So I just did the length, width, and height, obviously, and you can see that is your 50 millimeter cube. Again, drag and drop. You can move it up and down, change your colors. You know, if you want it blue, if you want it, whatever color is more appealing to you, we'll do Bitcoin orange, or whatever that is, yellow. That is essentially Tinkercad, what you just saw. But what's very cool here is you can go and make things transparent, as acting as a whole, if you will, acting as a negative object. So you can do some really cool things with this. So, for example, we can go and export this right now and call it a day. But instead of doing a circle, let's go and add some text here. Just very simply, you can drag and drop the text file. We'll just say, we'll just put pleblab on here for that. Perfect. Pick a different font, make something look decent. You can easily align these if you want. Click off, select all, and up at the top, you can see you either have a line or you can mirror objects. So there's different ways you can merge them, so on and so forth. We can align these, and then there's different ways that we can go and align these up. So we will put pleblab on the top here. Let me just shrink this down. I'm not really worried about size at the moment. You can drag it all the way up. We can move it around. You can see, but you'll see what I'm going to do here in a quick moment. I want to be quick here too for everybody. I don't want to take up too much time on this. Again, you can very easily rotate. You can drag and drop stuff. This is very childlike, but it does a good job. We'll just extend this out just for the example. So I want to make pleblab line up and make that as an acting whole. So it is I always get this wrong. Embossed or debossed? It's debossed in the square. So I will go and select all. I will line these up. Make sure they're, and again, you can rotate around, find the key shortcuts. We can center this here, and we can look right at top. Okay, it's going to be lined up. But remember, I want it flush. I don't want it sticking out. Okay, we can merge these together. You know, I can drop this down. We can merge these together, but it's going to be sticking up. I don't want that, right? So this is now one object. I just put those two together. I don't want that, okay? I want that to be flush, and I want it to act as a negative. So you can go and simply click pleblab, make it as a negative, okay? We're going to select all again, but this time we're going to align at the top level here, and that's right here. Now, it does move this up on occasion. It depends on where you're at. You do have to put that back down onto the work plane, or else you will export this as a model, and in your slicer, it will be slightly above, which will be very frustrating. You will not get a first layer print. That is a big key tip. But I'm satisfied with that. I will go and merge these together. We'll click group. And now in one print, I have pleblab embossed, as you can see, or debossed on the inside here. And then we'll see what the layers look like as it's being built. Actually, this is a good test. I should have did this instead of a bench sheet. Again, but make sure that this is dropped to the work plane. You can see it at the bottom here. You can move the scale too, down at the bottom if you wanted. You know, you can make it more refined, but one is fine for what we're doing there. Put it at 0. And this is done. We'll just leave this as is for the example. This is how you export. Click your single object at the very top, click export. You have these 3 options. I encourage you to use STL, the easiest. OBJ works fine, but if you wanted to do laser cutting, you could, but STL is preferred. And then, of course, name it. We'll just do lab cube, and I know it's not a cube, but we'll leave it simple. Throw it up on the, actually, we'll throw it right there. That's perfect. I will go and find that, put it in the file. Oops, where did this go? Oh, it's just opened. Oops, there we go. Okay. Nope. Cancel. It's another CAD software, sorry. Too many CAD programs, people know. Where'd she go? There we go. Find your file. This is your STL. Okay, this is what you want to see. We will go and be using Prusa Slicer for your slicing software. This is your workflow for Prusa Slicer. We can use Cura. There's Idea Maker. There's other ones as well. I think some other ones down here too. Idea Maker as well, Cura. Different versions of Cura as well. This is, I'm more comfortable with this, but you pick what is most comfortable for you. Simply go and drag and drop your model into your slicing software. And actually, I feel like I'm getting ahead of myself. So we will stop right there and go back to the slicing software very quickly. So that was a Tinkercad quick demo. Let me go back and play that here. So now into your slicer. Again, it takes your STL and it converts it into G-code. The G-code is what is actually machine readable. It is literally a text file that says very specific coordinates of move the tool head here, extrude X amount of plastic at Y direction, at Z speed, and you get your model. Once you're done, move up to the next layer. 10,000 layers later, you get your object. Prusa Slicer, Ultimaker, Cura, we've already talked about those. Again, these are the coordinates. What the Slicer software does is tell you how to print the model. If you don't let the machine know what you're going to do, it is anything else like code, garbage in, garbage out. If I tell it to print at 500 degrees, it will attempt to print at 500 degrees. It will probably fry something, as this particular one is not available for high temp. So you need to be more specific at what you are asking it to do, just like regular code. What temperatures, how fast you're moving it at, what material, so on and so forth. And the output file is G-code. Again, we're using Prusa Slicer, and do a very quick demo of what I was just showing you here. We just drug and dropped the model into Prusa Slicer. And as you can see, we're basically ready to go. Prusa and many other slicers do a good job of just having everything with presets. You pick your layer. We'll do it more simple here. You got different settings, different materials. You know, what is your machine? How tall are your layer heights? That's really what the main thing with 3D printing is. It's your layer heights. How tall do you want your actual model itself to be? Meaning the resolution. I should rephrase myself. How high quality do you want your part to look? The more high quality, the longer it might take to print, but you'll get a better result. So you have different speeds. You want to go really fast or super, super high quality, but it might be very slow. And again, we're not going to go into all the settings, but yeah, I'd only put it on, you know, you can see all the advanced extra settings and things of that nature you can do. But layer heights, you know, what is the solid, the density on the inside? What is your infill? So on and so forth. How fast you printing, your extrusion width, so on and so forth. You pick your materials. What temperature are you printing at? We're going to be doing PLA. This is actually PETG at the moment with a benchy. And you will see your machine settings as well. So you can go and, you know, fine tune those. Go back to the platter and we'll just show you a very basic slice. I will actually bring in the benchy as well, just to do this, to show you what we are actually printing. And where is my benchy? I wanted a benchy STL. What do we got? That's fine. So this is what we're actually printing. And actually that is not what we're printing. I apologize. It does not look like that. I grabbed the wrong one. Let's see if this one's it. There we go. Okay. Actually, that's that's why. Okay. Actually, oh, I see that. Where she go? Here we go. Perfect. Okay. This is what we're actually printing at the moment. This is what we're going to see come out. I will actually pull that off to the side there. But you can go and actually slice this. Click at the very bottom, slice now. I'm going to print at a 200 micron layer at 0.2. It's pretty quality, normal PLA on the machine, only 50% infill, so that's how solid it will be. And we'll see how long both of these will take together. The Benchy only takes about an hour. We'll see how long this block actually takes. So you can see that this is how both of those are going to print. Again, we're only doing the Benchy right now as we just literally created the Pleb Lab logo. But this is what the slicer software means. We can scroll through the timeline. This is exactly how it's going to build. And you can see the toolpath per layer that it would move. Whoops, there we go. So you can see exactly where the toolpath is going to be at all times. How it's going to do the infill, the pattern size, so on and so forth. But that is the whole point of your slicing software. You build things layer upon layer upon layer. And if we printed both of these at these default settings, we can make this much quicker. This would take about 6 hours or so. You can go back to the platter if you want. Let's just get rid of this, see what the Benchy would be. And yeah, you're at about an hour 20. This one's a little under an hour. So you'll see this exact model once we're done. But if you look right now, we are approximately somewhere about here right now. So again, that's how you're building it, and that's what the slicing software does. Go back. I think I can pull that back. Yeah. But I wanted to highlight one more thing here, really, just very quickly, just to emphasize here. You can see how that will build that top layer. Actually, we'll go down a couple layers. You can see how it builds around it first. Okay, you built those blocks. So again, it depends on how you make your model at first. Dictates the geometry, dictates how the tool head will operate. And you can see the particular pattern that this default setting will go and create for Pleb Lab. We should probably go and make this just to do it as a demo. So once you're done with this, we would go and click export. And then notice it will give you a little more detail here. It'll actually tell you what the layer height is, what your size, the material, and then most importantly, the machine, the time as well. But what you'll see is I'll put that in the file. We'll click save. Just show that in the file really quick. That's a .g-code file. So again, that's machine readable. And actually, while we're here, let's look at this. Where's text edit? Where's text edit? Let me just open this up in text edit to show you what G-code actually looks like. This is G-code right here. This is what the machine is looking at right now. These are literally just coordinates. Okay? Move 30 millimeters this way, extrude this amount of plastic. That's literally all it is, however many hundreds of thousands of lines. And then it's done. So that is what G-code actually looks like and what the machine is reading. So it is human readable. I go and actually make edits into this. I make my own edits, and I encourage other people to do that as well. It's easier than in here. So that is just a very high-level, quick view of your slicing software, and you will see what that Benchy will look like when it is done. So we're talking about the printer, and you're saying, okay, great. What does extrusion mean? I don't know what you're talking about. What is filament? What is a tool head? Let's just very quickly go through the anatomy of a 3D printer. You have your actual operating tool head, and that contains your extruder, if it's a direct drive, but don't need to get into details, and it will include your hot end, which gets into what actually melts the plastic. So it's very simple. It takes plastic on a roll, like a weed whacker string, a trimmer string, and it puts it into a small nozzle, a little orifice. I have, An example here, a very small orifice, and it extrudes that layer upon layer upon layer to build your model. There's usually a little guide in there as well to keep it from staying or keeping it melting at a consistent rate. But that's basically the tool head. That does all the work. You usually have a heated bed as well. Keeps the part adhered to the bed. The plastic is hot, the bed is hot, it wants to stick. You can see it's not moving. Let's cross our fingers and make sure that it continues to do so. I did wash it prior. Make sure you level your bed. The first layer is always the biggest issue. Make sure you level your bed, level your bed, level your bed. That's your foundation. If you don't have a solid first layer, the part will probably fail. I highlight that in a later slide. The prints probably fail, depending on what you're doing and what your output is, they probably fail on occasion, maybe 10 to 15, maybe 20% if you're just getting started. So don't get frustrated if 1 out of 5 fails. And then last but not least, you have your chassis itself that holds the tool head, hot end, and the heated bed together and have them operating in a coordinated manner through your stepper motors and belts and so on and so forth. There's different styles of 3D printers as well. This is the most common and this is the most versatile. You'll see this in the exact same thing for 3D printing homes and 3D printing livers or biology and other things of that exotic nature, which is very cool. This is a little more higher realm. It is very nice to have a monitor to kind of watch what you're doing. This is just a very basic default monitor. We can get a nice upgraded one. You can have a camera monitor in this with either Clipper or Octopi. And you can even edit on the fly if you want. And then, of course, you actually got to hold your spool holder. You need to hold your actual roll of filament, which is your spool. And it's really nice to have a filament guide as well, so the filament isn't dragging on the frame or getting caught or tangled in a different part of the chassis. So that, of course, holds it in place, and it does help it to freely rotate if you do notice this constantly slightly moving. So again, you can see it live working in demo as of right now. It is moving back and forth. I can't see how much time we have left on there, but it's roughly default settings, but on occasion you'll notice the filament, rotate. This is PETG, so it does print at a higher temperature, but it can stay outside a lot longer and it's not going to warp in the sun. That's what most of these materials are actually made out of. So this is the printer chassis. Again, tool head is moving. You got a fan, you got a direct drive, so the filament is being pulled in instead of pushing on a string. I find Bowden systems are good for PLA, but for TPU, your flexibles, you really need to pull them in instead of pushing from afar. Again, it's a rubber material. We have spools over there, but you would see the difference, hard plastic versus a soft rubber band-like material. And of course, your bed is hot. This is all in Celsius, so 60 degrees, it's like 130-ish degrees or so. Same thing for your tool head. That's at 240 Celsius, okay? So you're at well above 300 plus, 350 plus degrees for melting that plastic. And it is amazing at how organized it happens. So again, the most important thing there is obviously making your machine calibrated properly. Level your bed. I cannot say it enough. Level your bed. Level your bed. Everybody say it with me. Level your bed. There we go. Yeah. But it is one of the beginning problems, if not of almost all problems, when you're 3D printing. You'll have a print kind of fail, slide off the bed. It might wobble, and you'll have a spaghetti mess in 20 minutes or half an hour when you come back. And yeah, it's a problem. It's really nice to keep the bed very level. There's other tips and tricks to do as well. Always have some isopropyl alcohol with you. I don't have towels, but I did wipe that off with a towel. It gets your finger grease off of the bed. Your finger grease, just a slight touching it 1 or 2 times, even if you just wash your hands, you can add just a slight amount of grease to go and put a slick layer where the filament might not adhere properly. Another good tip is the very strong sticky hairspray. That works very well if you have the strong version. Glue stick Just regular, not Elmer's glue, regular good old glue stick works wonders. I don't have any up here at the moment, but that works wonders to help it stick better. Again, make sure your motors are all checked in or plugged in and checked fine. I've had issues where the motor was not plugged in. It just rattled my brain for a day or so. It was funny. And if you just remove any of the debris that's where it's building at, obviously, make it clean. As I, just kind of said, make sure you're wiping off the bed, with either isopropyl alcohol. Honestly, soap and water work great. Windex is fine. Apply a glue stick if needed, not always, but if needed. Definitely do this when it's not hot, but it does help if it is a little bit warmer. It evaporates the alcohol or dries a little bit quicker. And of course, you're done. Just print. Most are on a micro USB or on a SD card. So you can take that G code and put it onto a SD card. You can see it sticking out on the side here, or you can have it be connected right into your computer and just send the file remotely. Select the file you're printing. Go. Keep printing. And that's what you obviously see here. So just some very quick tips. Watch, if you're going to stick around, printing is slow. It's going to take a while. I think this tire kind of coaster or koozie, I think this took like 6 hours, maybe 7 hours. Just stick around for like the first 2 layers and make sure that, I thought I was moving. Thought I had a heart attack. Make sure that it's sticking around. First layer, second layer, might take, first layer usually goes slow, but, kind of stick around and make sure everything is sticking to the bed, laying down properly, and not going to move. Again, like I said earlier, your prints are going to fail as you get started, especially if you're doing a new model. Again, the most common question I get asked is, great, you got all these printers, you build these farms, and like, what's your favorite thing you print? How many different pictures can you draw? How many different, photographs can you take? I can print anything. Again, we can print concrete houses to, plastic koozies to, actual functional parts. This is for a industrial product, to, bio, livers, the stem cells and stuff that you can 3D print, chocolate and like what geometry do you want to print and what material? And it's just infinite amount of opportunities and variations that you can go and manufacture. Again, that's why I love the mantra: thoughts into things. I can manifest any thought I have into a physical thing. I can think of something, draw it out, extrude the drawing, and then actually put it in my hand in like 60 seconds or 60 minutes or less. That's the power of 3D printing. Kind of one of the last things, and we just said it before, the bed is not level. That could be one of the major problems, even if it's slightly off. Auto bed leveling helps, like a BL Touch. Prusa has their Pindas and other auto leveling systems. Others have theirs as well. Voron's, we used to do the Clicky Probe, and there's many other different variations. But the software and hardware integrations have gotten better over the years to compensate for these issues that you have. And, sometimes you might be printing PLA too hot or too cold. Too cold, it will kind of not adhere properly. Too hot, it just kind of smears a little bit and it gets a little stringy. So you'll notice that right away. This goes into that fifth and kind of last point where what post-processing is needed. Hopefully none. So we're going to take this off here in, I don't know, maybe about 20 minutes or so. There's probably not going to be 28 minutes. Thank you, Logan. 28 minutes is left. You're probably not going to have too much. Like this particular part, when I took this off the bed, it was just like this. I took it off the bed. Whoops. I kind of looked at it. I'm like, all right, I kind of cleaned up, maybe a little string in here. But I had the settings very refined, and I didn't have too much stringing in all these, little holes. So I took it off and I used it for the industrial application. Sometimes you luck out in those scenarios and you want to build those models in the software beforehand, okay? Not rarely, but on occasion you will make a slight error that I highlighted earlier. of where either the CAD model or the slice itself could have been slightly off, incorrect for what you were choosing to do, and that would get a incorrect print. So if you know your machine is calibrated, and you can guarantee that with a test print, something shorter than a Benchy, a 3x3 square, or whatever else, that really helps to say, okay, I know this machine is good. What's my slicing software? What's my CAD model issues that I have? Again, keep, any stringing that you might have, kind of pull that off. A heat gun works well. Even a hair dryer, works fine. That helps clean up a lot of stuff. If you have any supports or bases, maybe you're doing like a right angle. It can't 3D print in mid-air, so not yet. So you would have supports underneath this. That would obviously need to be removed and make sure it's clean. And if you really needed to, we very disincentivize any sanding or painting of prints because you just kind of printed it. You want it in that color or in that model. You can go and do excess post-processing. I know guys that and ladies that are in the cosplay and they make extravagant costumes and they'll sand down their Iron Man and they'll paint it and they'll, electroplate it and all that kind of stuff. So there's some really, really cool things you do with post-processing to come out with a wonderfully finished product. But those are just some slight tips and tricks for any post-processing. And that's it. You've turned your thought into a physical thing. So as we will see this print get done in roughly, again, 25 minutes or so by now, 26 minutes, you will see how that turns out. Just some quick things for what is upcoming for Eden3D. I didn't have this on here. We talked about it last month at SatsBuy. A really, really cool network that Super Testnet actually built to have you go and make your own store, to go and sell your own 3D printed products and find others in your area to do so with you as well. And receive that in Bitcoin if you would so choose. But really it's to build out a whole proper workflow and to have a more refined machine so everything is into all one single unit. Check out the socials there if you would so choose. And what else I have? Yeah. Thank you. Thank you very much. Yeah, please, thank you. Any questions on actually, before I get to any of the questions, before we open that up, we talked about it actually here about at Pleb Lab, and we had this issue prior. It's a very common thing, but this is very important as well. If you look at the other yellow box that I have with my filament in there, you'll notice that there's some very small blue silica beads at the bottom. That is to absorb moisture. Plastic sitting on a spool, just on a table for more than like a couple days will soak up water. It's hygroscopic. So it's going to attract water. Different materials, we didn't even get into the different types of materials. Different materials will absorb water at different rates. So it's really helpful for your printing quality. Say the machine is calibrated perfectly. Say you can guarantee that the slice worked. Hey, I printed it at the library. I printed it at my friend's house. It works, but I just can't get it to print. Try a different material. Make sure that your material is dry and preferably stays dry. And that's why you keep it in a dry environment with the silica moisture absorbing beads. You can get the color changing ones that help, but I know there's some environmental issues with those. But you can just put a little humidity gauge in a small little Tupperware or whatever those yellow lid black boxes are and stuff, storage boxes. And keep your filament in a clean and dry environment. You will actually get, nylon is atrocious with this, higher temperature nylon. And I actually noticed it here with some of my other filament that I had left out. Sometimes there will be so much water in there, I'm being a little exaggerative, but you'll actually see a puff of vapor come off the top, and that's just water hitting a 400 plus degree hot end. So it's very helpful to keep your material dry. And if it's not dry, be careful. advise you to have a parent with you, right? Or something. But you know, you can put it in your oven at like 100 degrees, you know, for 2 hours or so in a heater, just to kind of push out some of that moisture, but keep it in some silica beads. So any questions? I want to kind of add that there. Shoot it.
You're just talking about how moisture can really, let's say you've already had your plastic sitting out for too long. You, I don't know, like pack it in rice or however, like all the tricks that people use to sort of suck moisture out of something, will that work?
Of course, your plastic isn't going to go bad, okay? As long as you're not leaving it on, you know, okay, we're not leaving it out, you know, on the back patio or something, right, in the sun for 3 years, okay? You could put it in rice if that's all that you had. I think somebody even brought up salt at last time. If you wanted to, that could work. I wouldn't advise that. I would advise like, you know, the actual silica beads or something that we know that will absorb the moisture. But anything like that, as long as you're in that right mindset, if it's been sitting out for 4 or 5 months, you know, on a table or something, not a problem. Put it in the oven at 100 degrees for like 2 hours, you know, 90 degrees. Honestly, lower the better for longer, just to make sure it doesn't warp, especially for PLA, mind you. PLA needs to be more like 70, 75 degrees, maybe 80. You don't want to get any hotter than that. But as long as you're in that right mindset to say, all right, this has been sitting out for 2 or 3 months, I can put it in the oven, or I can, you know, put in some rice for a week or something like that. That would suffice. Shoot it. You had it up first. Yeah. We will use our handy dandy web search for that. Let's see. So the most common materials are PLA, and that's polylactic acid. It's actually a biodegradable material. It's just made from cornstarch. Yeah, here you go. This is a nice. It's honestly, I think they just have really good SEO, but it's pretty decent on just like a high level view of things. But your most common materials are going to be PLA, again, the biodegradable. It is lower temperature. This is PLA. It's lower temperature. It's very, very versatile. Okay. Easy to print, prints like butter. But it will warp. Maybe if you leave it, maybe you have something, maybe you did like a phone clip or something on your dashboard in your car and the sun, you know, is hitting on it for work, that might start to warp, okay? The glass transition temperature is what we like to refer to. What is the temperature at which the material starts to warp? PLA is around that 80, 85, and that's why I said if you're gonna put PLA in the oven, again, under that glass transition temperature. PETG is higher, but again, it's around that 100, 120 or so. But your common materials are PLA, PETG, TPU, TPE, that's the rubbery stuff. Basically, PETG is it's actually it's this plastic bottle. It's your milk jugs. It's your, I think milk jugs is hips actually, but it's your water bottles basically. It's your plastic Ziploc bags and stuff like that, just with added glycol, that's the G. But that's, you know, same thing. It's a little bit more harder. Most of those materials are going to be PETG. Some are PLA. I think the characters are PLA. I think that truck is actually PLA now that I'm thinking about it. And then your rubber materials, your common materials are, I don't even have it up on screen, I apologize. Yeah, PLA, that's just very common. ABS, more toxic to print, but it does a great job at industrial applications. If you wanted to use, that's what we use for our Voron printed parts is ABS or your higher temperature, you know, materials. Not so much nylon; it's a little too fragile for that. But why am I blanking on the other one? Anyway, but that's a good material to print with. The problem with ABS in these open air environments, and this is why I don't encourage people to do that. is print with ABS, it is toxic. So you will get the toxic particulates in the air, and there'll be like a sweet kind of smell. You don't want that smell. It's not good. Yeah, as sweet as it smells, it's not good for you. So if you do print ABS, we do sell ABS on our site. And I definitely highlight, if you are purchasing that, I will confirm with you that you are aware of that and you have an enclosure with proper printing filtration for that purpose. But again, you're going to get wonderful parts. They're pretty good about being UV resistant as well. But ABS is kind of a gold standard, but you don't print it in an open air environment. It'll actually warp if you printed it right now, because open air would, it needs to be printed with like an 80 Celsius environment. Okay. PETG, we just talked about that. Honestly, to me, if you're going to be selling stuff, if you're going to be printing things for like outdoor use or for hand it to somebody, print it in PETG. It basically prints like PLA, slightly different settings just temperature wise, but it prints just like PLA. Just make sure you print it hot. That's all. 250 at like, and put your bed at like 90. PVA, that's actually a water soluble material. So if I printed this out of PVA and I dropped this into a bucket of water, it would actually melt. So what's really nice about PVA is it is wonderful support material. So say that I had to, in all these holes here, let's just pretend it couldn't do that. I can go and 3D print the holes as PVA and the solid hard plastic as PETG, PLA, whatever you want. After the print was done, I can let this sit in, room temperature water for maybe, it kind of varies. You probably want to do it for a couple hours or so. It would actually dissolve, which is really nice. And all PVA is, it's literally a glue stick. They put glue stick on a roll of filament, which is kind of cool. Nylon, this is more engineering grade materials, higher temperature, higher tensile strength, things of that nature. I would not recommend, actually, the hot end does go up to like 275, 280, but with the PTFE tube on the inside, that material, glass transition temperature, is around that point. So that will actually start to degrade, and you'll see that into your print. So this is for more of an industrial grade machines, kind of what we sell, what Ultimaker would sell, larger, more industrial grade style machines at that point within enclosure, filtration, and stuff like that as well. Conductive, yes, they do make filament where you can go and lay a line and, put two LEDs together. But funny enough, carbon fiber actually works tremendously better than all these. I don't know why carbon fiber is so conductive, but like 15-20% carbon fiber. Kind of on that point too, a lot of this stuff is going to be embedded. You can buy normal materials, but maybe you want a wood finish, or maybe you want a, again, you want like a carbon fiber, kind of like a, like a race theme look to it. What else you got? You got wood, you got tough, you got PLA plus, it's more of a tough material. There's many, marble, you can kind of get like a grain look. Sand, there's tons of, wood composites. Hips, that's more of industrial material. Again, toxic, don't print it in an open air environment. And metal as well. I do not have any samples with me today, but I do 3D print either stainless steels or one of the companies just came out with their tool steel as well. We can do titanium just on these simple machines. There's just a little bit, yes, just a little bit different setups, but you will always have, anytime that you have a composite, right, that's blending two materials together, anytime that you're pushing anything through one of these machines, there will always be a little bit of PLA or PETG, ABS, something, nylon, to allow that to pass through the hot end, okay? So what you do for these metal composites are, the filament that I have is 85% stainless steel, 15% PLA. So I 3D print my model, and then I place it into a kiln and a whole sintering and debinding process to essentially bake out, without warping the geometry too much, of the PLA. And then you're left with a 100% all metal 3D printed part at home. Now, because there's a little bit of PLA in there, it will actually slightly shrink, maybe warp in certain areas, and that's definitely more of an art than a science, but you can 3D print metal at home if you so chose. We didn't even get into that too. Resin as well. You see liquid 3D printers. Nothing that looks like this. It's just kind of a box with a translucent colored lid for your UV light. It is essentially the same thing. Just invert this entire thing upside down and just remove the tool head. The build plate is on top and the liquid is on the bottom, and it just moves up 2, down 1. And what that means is it's touching the liquid, it flashes the light or it moves the laser, it draws your geometry, again, same thing, layer by layer, and it moves up 2 sections to go up the 1, let the excess material roll off, and then it drops back down for that additional layer. And then you just build it from there. Much higher quality, much faster. There's no, I'm blanking on the compounding term here. If you added 2 or 3 parts onto here, it's going to take like 4 or up like 8 times longer because it has to physically move there. If you had a big enough print bed, you could print one of these on a resin, or you could print 10. It's all going to print at the same time because you're all moving the whole layer at one go. So you're always better on a resin to do it all at once. The reason why I don't like resin, I love for the high quality, but with my sigh, it's toxic. You wear rubber gloves. It smells horrible. It's liquid plastic. Yes, it is as horrible as it sounds for the environment. God forbid, do not dump it down your sink. Okay, don't touch your face. So it's just not a fun process. But if you're willing to go through it, you'll get gorgeous prints. I don't mean to kind of extend out your material question, but that's just kind of the tip of the iceberg here. And they didn't even say any TPU, but TPU is the rubber material. Actually, yeah. What am I doing? Yeah. TPU is your rubbers. So, yeah.
What would you say, for a standard printer like this, like what's a good situation? Someone is like, oh, I got a good what should I think about using a printer like this? What should I think about using a advanced printer, and what should I think about?
That's an excellent question. I would look at what is your final output? What is your end goal for the product? For this particular product, I very lightly touched on it before. It's for one of our landscaping companies, and we were looking for a way to go and remove out of, or actually prevent any excess grass getting into the neck of the fuel tank. Okay? You might not think it's a problem, but it does clog up, and there's no filter on that one for that particular model. So I just whipped this up. Ironically enough, in Tinkercad. I know I'm probably making people flame in the charts. Go ahead, write the comments down below. Make sure you like and subscribe as well, please. I only wanted to make sure that it was a test and that it worked and that the material could withstand gasoline for extended periods of time. And amazingly enough, PLA and PETG held up wonderfully over the winter. I'm honestly kind of blown away. So, unfortunately, printing is limited. You can't do much on your overall output. Like you can't crank out 100,000 objects. That would be something that you would go and find like an injection mold or CNC at that point. But I would say look at what your output is at first. Is this something that I can go and find your local library? I need to actually make sure that Austin has one. A 3D printer at the local library. Nationwide, there's a lot of 3D printers at the local library and nobody's using them. So I know my hand is up as well. We all need to use them more. That would be a place to say, hey, let me test out my object. I know a friend that has one, PlebLab has one, the local library does. I'll go and print that, right? Or I'll have a friend draw it up or, something like that. Then I would argue if you're going to do this more often, definitely get a machine. And then now we're getting into that category just very briefly, like what we talked about earlier. And actual issues I know you faced, I've faced many times. We had that heart to heart there as well. You get what you pay for, right? If and it's just painful to say it like that, but that's what a $200 machine gets you or a $100 machine gets you. A Prusa is, a good $1,200, $1,300 all in. One of our Vorons is going to be $2,000. Okay. We're going to print a heck of a lot faster. You're going to do a lot bigger, so on and so forth. But at which point do you start to justify how can I essentially either get my time and value out of that $200,000, $2,000, $5,000, whatever number you're spending, or can I go and actually make money to do this? And of course, now that's a whole separate category. But I would say look at your output first. What is your goal? Are you just doing a quick prototype? Have a friend do it. If you find this fun, go blow $100 at Micro Center on a printer. And then if you like it enough, you're gonna go and sell that or upgrade your Enders and print it like a Prusa, or go and build your own Voron and print your own parts and stuff like that. So hope that answers your question and engage. Any other questions? All right, just very last thing here. Did I put that there? Oh yeah, there you go. Yeah, if you have any questions, shoot me an email. Honestly, hit me up on a DM Noster or something like that is good. Twitter. I rarely check Twitter anymore, which is, I guess, a cause of Noster, but it's all good. But thank you very much, everybody. Thank you. Like, subscribe, comment down.